I'm still a little skeptical of Starship ever being aircraft-like reusable just because it's not aircraft-like reliable. Even a Patriot missile system that's been around for 20 plus years, we don't really understand what it's capable of. The actual cost of flying a vehicle can be as low as 50K for sure. We're going to be flying to nearly 350,000 feet. The fastest anything's ever flown off a runway is about Mach 3.3.
Will Dawn eventually become a bigger company than SpaceX?
Depends how big space gets. Like with this SeriesB, we'll almost have equity sale catch up to real sale.
Just go and do it and see what happens.
Ideas are worth like jack shit, absolute jack shit. Like if you can't execute, there's nothing.
Just take that initiative to actually take whatever crazy ideas that they might have and just try to see what comes of it.
Don't be afraid of ambition. Chase it, love it, wrap your arms around it and say it out loud.
New Zealanders don't know any better. They will just get up and give it a shot. That's why we were first to get to the top of Mount Everest.
Go to dream that ultimate dream. Like, what is it that you ultimately want to do? And it's all achievable.
Cool. Yeah, Stefan, we had you on a year ago, a bit more than a year ago, for a very long discussion, hearing all about your background, your time in Germany and in going to a German kindergarten as a teacher. And yeah, since then, a lot of things have happened. So we're very excited to catch up and hear more about where things are at with Dawn. And yeah, to start with, since we spoke last year, we actually joined your cap table and we're super proud to be an investor now of Dawn as well in your current round that I would love for you to talk a little bit more about.
Yeah. Firstly, welcome aboard. Yep, things are certainly moving. Yeah, last couple years, there's been a massive amount of change in the company. Just like huge amount of momentum, especially in our spaceplane program. You know, where we've gone from it being like a prototype sort of product, and this is kind of what it can do, and it's interesting in some ways. Who knows exactly how? To now, like there is a cornerstone customer there. Essentially, like that partnership is really about funding that next generation of like the full performance version of Aurora that's going to demonstrate flying to space twice in a day. And it's really, even before the prototype is actually fully proven out, there's some sort of product market fit there. And now we're really sharpening up pencils on like what actually is this vehicle going to be used for in that first generation application. And that's kind of been a funny experience in the sense that it was originally intended as a technology demonstrator. So there was no original intention to go and find product market fit. But now that we're here, it's like, oh, this is actually a massive opportunity that we can't let up as a company. So that's kind of all, that's been happening. So Aurora was always envisioned as a technology demonstrator because it was all about like, let's just show that we can get to space twice in a day, that you can get like the performance of, the first stage of a Falcon 9 rocket, but in something that truly operates like an aircraft, like a, horizontal takeoff and landing. It comes back, you refuel it, and you're flying hours later, not days or weeks later. Like, don't get me wrong, what SpaceX has done is awesome, but it's not aircraft-like reusability. And to be honest, I'm still a little skeptical of Starship ever being aircraft-like reusable just because it's not aircraft-like reliable. Like, aircraft-like reliability is insane. Like, it's 10,000 times better than a rocket, even a Falcon 9. So to get to aircraft-like reusability is still a bit of a leap there in my mind. So Aurora was supposed to prove that, and we're well on the way to doing that. The thing that we didn't, maybe we were just too naive. We didn't realize that, if you have a Falcon 9 first stage, which is actually reusable like an aircraft, even at a subscale, it's incredibly useful for a whole bunch of other stuff. Suddenly, suborbital spaceflight becomes really, really interesting. Suddenly, simulating missile trajectories to improve missile defense systems, which is actually a way bigger industry than space launch, becomes really, really interesting. I think we actually just weren't clued into those industries. And that was because, I and 4 of the 5 founders came from a space background, and we actually just straight up didn't have enough exposure to these other worlds that we were inadvertently going into. So, now we're deeper into these worlds, and we realize there is a ton of commercial application.
We're going to talk about your Aurora and the refueling business as well in a minute, but also wanted to give you the opportunity to talk about the SeriesB, the $25 million that you just closed. So yeah, I guess, congratulations. And I guess that's going to be a great accelerator for both of those business lines.
Yeah, exactly. So the spaceplane line has come massively far forward. And in the meantime, the in-space propulsion side has really just gone from strength to strength. 2 years ago, we had sort of in the order of about 70 thrusters in space. We have over 200 now on 50 different satellites. And in terms of nitrous propulsion market share, there's about 63 odd systems in orbit that are nitrous bipropellant, and Dawn's about 52 of them. And, we've got another like 20 launching in October. So there we've kind of gone from like pioneering a small market, being one of a few players, to really dominating it. And I think it's fair to say, with like 90% of the hardware on orbit in the next 6 months is going to be like of nitrous space propulsion as Dawn. So yeah, what have we raised money for? Like doing all this, we've actually gotten to cash flow positive. Like we've been putting cash away in the last 6 months, and we'll continue to for the next few. So why did we go and raise money? Because I think we have an incredible technology position, but we can do so much more on the business development side, and we can start leaning into the successes that we're having. So with more cash, and it's actually not crazy amounts of cash, like we don't actually need hundreds of millions of dollars just because of how different the way that we develop technology is. With relatively small amounts of money, small amounts of dilution in the business, we can have disproportionate acceleration in the business. So really, approaching the market, especially the US market, in a much more serious way. Sales it's not cheap, and it is a long process. So that's one that we're really stepping into in a big way, and we want to invest heavily in. Same in Europe. There's a massive uptick in spending. There's huge geopolitical shift. NATO spending's going from, it's just gone through 2%, and some countries are going to 5%. Like I think the German federal spending in the early 2030s will be like 25% defense. They're going to be spending $35 billion over 5 years on satellites.
Yeah.
Like that is crazy. That's a tectonic shift, and we're super well placed to have a significant role there. So the key technology that we want to unlock is refueling. So that's where we take our nice satellite propulsion business. Great to replace hydrogen. Great to have a more scalable way of doing stuff. That's where we go from that being a good step forward to being a total unlock of like you get a strategic capability. You can refuel your satellites, massively drop capex of a satellite constellation. And for defense users, it's an absolute critical piece of deterrence. Like their satellites need to be refuelable so that they don't have their capability depleted. So SeriesB unlocks all that.
And just as a reminder for the viewer, so Dawn has two business lines. It's the satellite propulsion business that you've been talking about that includes refueling infrastructure, and then the spaceplane business, Aurora. And maybe to start with, going a little bit more into the propulsion business. I think last year when we talked on the podcast, you said, and I can quote from the transcript actually, you said, one day you'll be able to actually get refueled by a Dawn satellite or some other satellite, but that's a very long way away. That's what you said last year. How far away do you feel it is now?
So the intention is that we're doing that in mid-2028. So in startup world, I still feel like that's a long way away. But yeah, I suppose it's really only 2 years away. Like that's what our schedules are. Like that's what we're locking into. Yep. So that's.
And why refueling? Maybe you can lay it out a bit more why that is such a critical thing to do to lower costs and create infrastructure in space.
Yeah. So the starting point, like the first people who really, really want this capability is defense, because there's a problem right now where there's quite a few satellites especially in geostationary orbit. So like why is in-space refueling so important? Like the first users is going to be defense, and that's because they have a really critical problem right now, which is especially in geostationary orbit, they have legacy assets that have a limited amount of fuel that's baked in, that's not going to change. You can't refuel them now, and they are having that fuel depleted by other adversary satellites just coming around, poking at them, sort of sniffing their packets and getting up in their face, if you like, and forcing them to perform maneuvers. And every time they have to perform a maneuver that they didn't intend on doing, that reduces their mission life. It degrades their capability. So many space forces around the world are rushing to get what they would call like bodyguard satellites into place, so that you have a satellite that can get in the way of the satellite that's about to get in your way, that can fend these ones off. And ideally, these bodyguard satellites are refuelable so that, this this bodyguard capability doesn't itself get degraded. And if you have that and you publicize it, then it's much much less likely that your adversary elects to come and contest you, because that they know that they're just going to degrade themselves more than they're going to be able to degrade you. So this is deterrence in action.
Stefan, is that a function of the fact that the adversarial satellites do not have a refueling function? Like, if they eventually also get refueling functions, then that sort of becomes a moot point, right?
Well, absolutely. I mean, this becomes an arms race, like of mobility. So you want to be ahead of that, right? So you got to get your satellites to be refuelable, and then you've got to have a bigger stockpile of fuel, and ultimately like more mobility. But this becomes a logistics battle. But yeah, the current state is no one's refuelable. They're all single-use assets, single fuel tank assets, if you like. So that's the first users. Everyone's kind of pointing at late
The
20.
first users are the bodyguard satellites or the Bane satellites.
Well, even the bodyguard satellites at the moment are single fuel tank. But it's better to degrade the fuel tank of a bodyguard satellite than it is of your $1 billion asset that's been there since 2015 or something.
Right. And you guys have figured out. I mean, because like your whole kind of thesis is very interesting, which is that like it's a chicken and egg problem, right? Where like if there are no refueling satellites, no one's going to put a way to refuel their satellites on the satellites, right? And then if no one puts a way to refuel satellites on satellites, there's no market for a way to refuel satellites, right? So it's like if you don't have like the gas stations, you're not going to make a gas tank in a car, right? And there's no gas tanks or gas. So you guys solve this in a very clever way.
Exactly. Like that's the classic chicken and egg problem. And that's I think the mistake that a lot of like satellite refueling startups are making, is that they're rushing straight to the application, which is, of course, satellite refueling is where the money, it's where the application is, like that's what everyone needs. But you can't just jump straight to it, because even if you just clicked your fingers and had a refuel, like a fuel, like a gas station in the sky, if the idea was, hey, I'm a startup, please fund me so I can put this gas station in the sky, and then 5 years later, hopefully I get some revenue out of it, it's not particularly attractive. Our approach is completely the opposite. We actually started with the fundamental fuel of like what's a refuelable, scalable fuel, and then we'll build a thruster. And we started launching that. And, D-Orbit was the first company that put our thruster in space. This is long before we even built propulsion systems. And it's okay, people don't want to buy just thrusters; they want to buy whole propulsion systems. So now we're producing whole propulsion systems, and that's the majority of what we do now. We'll build about 50 propulsion systems this year. And now we can start, because we're a major supplier of propulsion systems, we can start replacing the, what would normally be the fill drain valve, like where you would fuel the satellite up on the launch site. You can just make that the port that is also a dockable port in space. So, replace the manual fill drain valves and replace it with a passive side docking adapter that they can use in space to refuel as well. So you kind of delete an old component, put in the new component, and now every propulsion system you make, even if they actually have no intention of refueling it, it's at least prepared for it, so that when they do run out of fuel, they can make the credible decision of, hey, do I actually want to refuel this thing instead of rebuilding a whole new one? If that's a credible decision they can make at the time, I think that's an idea
totally.
Customers right now can buy into and say, yeah, it would be nice to have that optionality. I certainly won't pass it up if I can get it for free.
But the real question though is like, why can't you use those fuel ports that you're replacing? Why can't you use those to refuel in space? And second question is, why aren't other thruster companies doing the same thing and putting a way to refuel into their thrusters? Like, it seems like, like if you guys are just replacing the port, right? Maybe somebody could have actually gone and refueled through the old port.
Yeah. I guess the problem is that nobody's known what ports to just put on there, because no one's known what refueling service is going to come. So there was no obvious answer for like, oh, what should you replace it with? There is no obvious standard. So I still think it's really hard for the industry to come up with any sort of standard. And what's going to become the standard is just going to be what's the most prolific. So that's kind of why we started on like, let's just be the most prolific. If we can be that, then there's also the biggest commercial imperative to actually start refueling, because there's a significant market out there of satellites with our refueling port of it.
And why haven't other companies who make thrusters do the same thing?
They just haven't had a strategy of being vertically integrated. Like most companies that build thrusters never even got to the propulsion system step. They just supply the thruster. So, they're like two major thought processes away from like, let's be a refueling company. And then most people who decided there's value in being a refueling company decided that they would jump straight there. They probably buy in thrusters, like, an Astroscale, for example. They buy thrusters from various different parties. And they've had some success, but it's a much bigger chasm that they have to cross because they want to go straight to being a refueling company, while we're able to take things much more bite-sized. And every step of the way, building thrusters, that was a profitable endeavor. Building propulsion systems now, that's a profitable endeavor. We can keep doing those things, and even if the next step fails, we still have an underlying good business.
I mean, it makes a lot of sense, but how is it that you were able to do all these things? And I guess the thruster is sort of a subcomponent of a bigger propulsion system, right? So why aren't other companies that are either building thrusters, why don't they graduate up to build propulsion systems? Like, how have you guys been able to do it and also do it profitably?
Yeah, like part of it's timing. Like, I think we came into the market really at the right time, like just when SpaceX was kicking off Transporter. Like, that was when our thruster development was just kicking into high gear, and we had a first customer. And then suddenly effective and cost-effective propulsion really became needed at scale, where previously it was never really needed at scale. But, we as a business always had this theory that space is going to come out of being a niche and into the mainstream. We're going to go from tens or hundreds of satellites to thousands, tens of thousands, and soon hundreds of thousands. So, that's scalable, sustainable space transportation. We had that vision early on, and I think we just kind of nailed the timing. So to some extent, that's getting lucky. But the other reason, I think, is just raw execution. Like, if you look at businesses in space, there's a lot of them. Some of them have great ideas, some of them not so great ideas. But the real differentiator is the ones who can actually build stuff in a cost-effective way, ship product that works, has shit on orbit, and you can check the TLEs, like, does it maneuver, does it work? You'd be surprised how many ship product that never does a maneuver, or it takes 5 years from the first one to actually have something going well. Same is true on the spaceplane side. There's a lot of launcher companies that have never flown yet, or never flown anything successfully, even suborbitally. So
Yeah,
we've built a good muscle of just actually executing really hard engineering year after year.
And let's talk about the spaceplane business a bit more. So the whole philosophy behind this is it's essentially a plane that has the performance of a rocket. How many times have you flown this now?
64. Honestly, I lose count. But yeah, in the 60s now. And so a decent amount of flight heritage is there. And we've done that over a number of campaigns. Yeah, we're now in a big upgrade cycle to, we've kind of gotten to the limits of performance of the airframe that we had. And now, we're rebuilding that vehicle to be able to fly to 100 kilometers altitude. And then, multiple times a day.
And can you remind the listeners, we talked about this last time at length, but why is this such a big deal? Why did you come up with this concept in the first place?
Yeah, like, it's the same thing on the satellite propulsion side. We had this vision for there's going to be a lot more satellites out there. Everything that we have to do has to be much more scalable and much more sustainable. And the key bottleneck in space launch is reusability. 10 years ago, some people thought you could get around this bottleneck by just factory producing a lot of cheap rockets, and I think that's been pretty solidly debunked. I think everyone realizes reusability is the way, and people start to talk about aircraft-like reusability. I think we're probably the most hardcore in trying to be aircraft-like, and in that, following that theory, if you like, we build aircraft that are certified as aircraft. They fly, horizontal takeoff and landing. The only thing that makes them a rocket is the fact that it has a rocket engine on board, not a jet engine, and that just allows you to get beyond the performance constraints of a jet engine and beyond the reaches of the atmosphere. So, there's no fundamental reason you can't get rocket-like performance out of something that looks like an aircraft. It's really just a question of how good is your engineering? Can you hit the mass fractions you need? Can your rocket engine have the performance that you need if you're staying away from things like cryogenic propellants? Because, things like cryogenic propellants, like aircraft don't use cryogenic propellants. They can't, they need to be mission flexible. If they have a 30-minute delay, they have a 30-minute delay. You can't let that, boil off so much propellant you can't operate now.
So Stefan, just to maybe kind of take it back a step. So you basically built a plane that uses your thruster and propulsion system, which has a special type of propellant that doesn't boil off, that is not used in typically in rockets, that can basically take this plane to 100 kilometers above the Earth's surface. And this is an unmanned plane, right? There's no people inside.
Yeah, exactly. It's an unmanned aircraft. The propellants are not particularly special. They've been used since the 60s as well. It's just that they're non-cryogenic, hydrogen peroxide and kerosene. But yeah, it was an exercise in taking a lot of existing technologies. Like no single bit about it was like crazy new science project needed a rotating detonation engine or something. It was all existing technologies brought together in a new way, and to make a genuinely new product, which is also certified under aircraft law and uses runways. I would say it's actually very similar to what SpaceX did with Falcon 9. Like almost nothing about Falcon 9 is revolutionary at the component level, like open cycle, locked kerosene engine, aluminium structures, even vertical landing. Like we vertically landed on the moon in the 60s. Like it's not new, but bringing all of these things together.
Wait, Stefan.
In
I
a
thought the
new
moon
way.
thing was a house. I thought they just
Yeah. Well, if you think that one's a hoax, like there's it's been redone in the 90s and in the 2000s again. SpaceX is not by a long shot the first people to vertically land a rocket. So, but but no one debates that Falcon 9 is an absolutely revolutionary vehicle, because it is. But it's revolutionary at the system level. And it's revolutionary in terms of the economics. So in the same way, that's how Aurora should be revolutionary. No, it's not a science project at the component level, but it's revolutionary in that you will have rocket performance, but you will have fleet economics. Rocket performance, fleet economics.
Yeah.
That's the huge unlock, and that means you can do so many things that you could never do before with a rocket, because the economics is just limiting.
Help me understand. So, can you take an existing, like, I took a plane, earlier this afternoon, and can you just put your thruster on that, passenger jet and just take it all the way up 100 kilometers, or if no, why not?
No, the short answer is no, because the aircraft are very highly integrated things. Everything interacts with one another. So. And being a rocket, it's very, very good at short bursts of high performance. So the intent is not to replace existing aircraft. The intent is more like to replace existing rockets. So what's the effect? What's the point then? Anything that I would have loved to be able to use a rocket for, but it was just horrendously expensive, like way too expensive for, I can now do with an aircraft that has the performance of a rocket. So, for example, billions of dollars is spent a year on missile defense systems. Hardly any of them are actually tested effectively or to their limits. So people don't actually understand the limits of capability of these systems. Even a Patriot missile system that's been around for 20 plus years, we don't really understand what it's capable of. The troops that use these things are not actually as well trained in live fire situations as what they could be. The radars, billions of dollars of radars designed to track all these different and new threats. We don't understand them as well.
So why is that? Why is that? Is it because we don't want to pay money to launch missiles and intercept them? It costs too much, or why?
Yeah. That's exactly it. Like, missiles are extremely expensive and they're extremely dangerous. So if you want to go actually test your radar and actually test your troops in a live fire situation, you have to go out to a firing range, and a missile's going to cost you easily millions, often tens of millions of dollars per flight. All of these things, like if you could just go and do this test for 50 grand, because you can fly a vehicle that's truly an aircraft, and you could do that test every other day if you wanted.
Are you saying your planes cost $50K
per flight? If you own and operate an Aurora, the actual cost of flying a vehicle can be as low as $50K for sure.
And whenever you're doing some kind of test with an Aurora, so it's not you're not actually intercepting the Aurora, you're not hitting the plane, right?
Great. No.
Then how are you actually live testing?
So the test of all of that system, like firing the missile, is the very last thing. They would talk about find, fix, track, target, engage, assess. They call F2T to EA. So that whole process, only the second to last bit is actually firing something. That F2T2 part is all about radars tracking and assessment, coordination of firing solutions, all this kind of stuff. Like that's actually where the majority of cost and training is. So you can do all of that stuff without actually shooting a missile at all. So yes, of course you could shoot it down as well. As soon as you're firing something, your interceptor is probably at least high single digits to multi-digit million, like tens of millions per shot anyway. So, even if the thing you're hitting is millions of dollars too, you're pretty committed to a high cost exercise at that point.
Yeah, and just so people get an understanding of what these missions actually look like, you've just done one in New Zealand, like a defense New Zealand in March, and you're going to fly from Oklahoma in 2027. Can you talk a little bit about those two missions and what they're about?
Yeah, exactly. So the DARTY mission was the Dawn Aerospace radar tracking experiment that we did with the New Zealand Navy. So they brought down one of their frigates. They parked it essentially off the coast of Tawhaki, the National Aerospace Center where we fly, and we flew up to high altitude, and then flew. It's called like a missile-like trajectory back towards the ground, as if we were engaging the frigate. Now we could do so. We still keep pretty healthy standoff distances, but you can do that sort of exercise, and we did that a couple of times for them, which allowed them to train, try some different settings on their equipment, and start to understand the actual limits of their radar. Now, this was really just a capability demonstration to show that we can use these new generation vehicles. That they would typically have done these sorts of tests with Learjets, but they can get a much more credible, threatening missile simulant with the Dawn product. So that was like a new thing for them to be working with a New Zealand company on this. Totally new vehicle, totally new trajectories, pushing the limits in lots of ways for their gear and for their troops. And yeah,
So,
really.
Stefan, but how is your plane different from doing it with a different plane? Like, what makes Aurora special? Like, if it's something that's coming down from high to low, aren't all the objects following the same trajectory? What makes Aurora different?
No, I'm like a Learjet that has a service ceiling in the sort of 40,000 feet, and it's flying reasonably slow, like Mach 0.8. We can fly very high, very like steep up 80-degree trajectory. We got to mid 70,000 feet on this trajectory, so we're like twice as high as what a Learjet would be able to fly at, and then we're able to fly a very steep, aggressive, and even supersonic descent trajectory as well. So that's much. It's just without going into too much detail, it's much more aggressive than what you'd be happy to do in a piloted
And is that
aircraft.
because like a regular jet has a person inside?
Yep. Yeah. And most regular jets have much stricter limitations on speeds and altitudes that you can fly. Like very few jets could even get to 70,000 feet. Like that's incredibly high. Most top out in the 50s or the 60s. Commercial jets in the 40s. But even military jets really struggle to get to these altitudes. But I would also stress this is the lowest performance aircraft that we'll ever produce, and it's already at the upper end of performance of what any aircraft can do. The highest an aircraft has ever flown off a runway was 125,000 feet. We're going to be flying to nearly 350,000 feet. The fastest anything's ever flown off a runway is about Mach 3.3. We're going to be getting to Mach 3.7. The highest climb rate to 60,000 feet was an F-15, doing it in 122 seconds, and we've already demonstrated 118 seconds. So,
Wow.
Aurora is a relatively modest performance version of what we want to be doing. We'll be the highest flying, the fastest flying, and the highest climb rate aircraft ever produced. And that's really what the performance of a rocket in an aircraft really is. Like it's insane by aircraft metrics, because it really is a rocket.
And Stefan, like there's now in Ukraine or recently Russia's using hypersonic missiles, and those are, from what I understand, like impossible to intercept. Does Aurora simulate or allow people to simulate hypersonic missile and in turn build defensive systems against that?
So Aurora can help. Aurora tops out in the sort of mid Mach 3s. So it's certainly not hypersonic, but when people talk about hypersonic weapons, that are usually actually meaning something that flies quite fast, but is also very maneuverable. Like even a V2 missile, that the Germans used in World War II, like that was hypersonic, but people don't really call that a hypersonic weapon because it's just a ballistic missile. Hypersonics is really about that combination of speed and maneuverability. So Aurora can help there. next generation aircraft will be able to help even more because they'll be significantly faster and more maneuverable as well.
Can you talk a little bit about the contract with Oklahoma and the work you're going to do there?
Yeah, absolutely. Yeah, so I would stress like defense is a part of our work, but Oklahoma is a really great example of where there's very much a civil side to these applications as well. So yeah, Oklahoma, like the state, has partnered with Dawn. We're essentially setting up like the first space line, if you like an airline with a space capability at their Infinity One spaceport in Western Oklahoma. So it was an old Air Force base, and then after that, it was a emergency landing site for the space shuttle. So it has some pretty unique airspace, airspace to infinity, which is great because we need that. We're going pretty damn high. So, it's a great place to put a space plane. And we already had a lot of interest from many different research institutes around Oklahoma and the wider country to come and do all kinds of things, all kinds of microgravity experimentation for like biomedical and pharmaceutical industries, as well as for semiconductor, as well as developing avionics and all kinds of stuff for high-speed drones. Yeah, lots of interested parties that are going to come to Oklahoma and use this spacefaring capability because Aurora operating at Burns Flat at Infinity One spaceport is that's going to be the busiest suborbital spaceport in the world. We're going to be doing 100 flights a year there. So they're very excited about that. We're super excited about it. We should be there in 2027. We'll start flight operations.
Let's talk about the industry in more general. I think this will probably air after SpaceX has gone public. We're recording this while they've already filed their S1, but before they went public, so we can't really speculate on what's going to happen. Otherwise, we'll look bad. I just kind of, using that moment to talk about how you see the space industry evolving and what that IPO means for your industry that you've been operating in for the last 10 years.
Yeah, I mean, like SpaceX is kind of the poster child of the space startup, right? Like it's been wildly successful, and the valuation that they're bringing to this IPO, like it'll be the largest IPO ever, I think is kind of indicative of that. It's a whole lot of hard work coming to fruition. What does it mean for the rest of the space industry? I think it'll certainly be a big tailwind in the sense that it'll bring a lot of attention to an industry that's had an absolute ton of growth, and I believe it still has a lot of growth ahead of it. Like we're still kind of at the start of some really big technologies actually being profitable, world-shaping technologies. Like Starlink is still a nascent technology, but you can see now from the financials, Starlink is a strong business. Like it prints cash for sure, and there's plenty of scope for that to continue. And space launch, I think everyone in the space industry now knows and understands it to be such a strategic capability. And I think that'll only be strengthened. Like people will really start to dig in on what does space mean as a technology, but also as like a sovereign capability. Like why is this important for nations to have? People are starting to wise up to the fact that it's kind of non-negotiable if you want to be at these, be like a strategic world player.
Yeah. And Stefan, what do you think SpaceX gets wrong?
What do they get wrong? Oh, I mean, the space nerd in me is a little bit like, hates it a little bit that XAI got tacked on the side. We'll see how that plays out. But it's like, I loved SpaceX as a pure space play. Maybe I'm not across or deep enough into AI to really understand.
Well, I think the idea there was like,
but
there's like orbital. Well, I think there's two arguments, right? One is that it was bleeding cash, and then they needed to like have it not bleed so much cash. And then the second was the data centers in space.
Yeah. So the former, but it's like XAI should have figured out its own cash burn. But
right.
But the latter, the latter, I don't know. I'm naturally a skeptic. I think we built Dawn on the principle of I don't know what's going to be valuable in space. I only know that there's going to be a lot of like there's about 10 different things it could be. Orbital data centers is kind of the latest hype. We'll see how it plays out. I don't know if it's actually if it's the thing or not. But if it is, they also have to get to space, and they'll also need mobility when they get there. So we're going to bet on the mobility part. I'm pretty sure that's solid. But yeah, that's a big leap of faith. in my opinion.
Yeah, I mean, even without XAI, this would have been $1 trillion plus IPO, right? They were talking about these numbers before they decided to roll in specs XAI. Yeah, do you think that that's going to kind of signal to investors in the market that, you know, there's lots of growth in space and you can build like huge, like $1 trillion companies? And how do you think it's going to affect your journey over the next 3 years?
Yeah. Like in terms of hard financials, I think it makes people realize that you can't just price space and especially launch as any old hardware company where you get somewhere between 3 and 10x revenue, and that's your valuation, because it's just way more important as a technology sector than that. Like, it's a sovereign capability. It unlocks. It is the road to the gold mine of space. So, how much of an extra toll, if you like, can you charge on the road to the gold mine? Quite a lot. And I think like Rocket Lab is already seeing this. They get way over a 10x multiple. They're more like in the 70s or 80s now, which is, it's kind of getting almost insane. But I think that whether 70 or 80 or 100x is the right multiple or not, that's not the point. The point is like, this is not a standard technology. You can't just price this in the same way that you could some other, whatever, car manufacturing or something, some other technology sector. This is really important strategic capability that nations depend on, and they'll pay a premium for it.
What do you think about, I think there's always concerns about SpaceX and Elon sort of, having control personally over such a critical piece of infrastructure, whether that's for the US, whether that's for the global, sovereignty of other nations. I mean, like, it made such a huge difference again in Ukraine when he turned off Starlink for the Russian army. Like, at that point they stopped advancing and Ukraine actually retook the initiative. And it was really, really, like, he's sort of like able to single-handedly determine the outcome of like wars, right?
Mhm.
And folks are a little worried about that in some cases. What do you think about that?
Yeah, I think you're exactly right, and you see that worry playing out in real action. Like, that's why Europe is getting serious about space. That's why Germany's earmarking $35 billion over the next 5 years to build out similar types of capability. That's exactly why that's happening. Because you're right. The world doesn't want to stay dependent on Starlink, at least not as the only option. It probably doesn't matter if it's the most economic best option, as long as there is some sort of backup that you can pay some high price for, in a wartime scenario or whatever. You can use that, or a business is not completely, paying monopolistic prices, because there's at least some sort of semblance of competition out there. Like that's important for the world. And I think that competition will then, it'll not just be in broadband, it'll also be in Earth observation, and it will not just be in competition in the US, it's in Europe, and it'll be in Asia, and, basically every major strategic player on the world stage will need to have these sorts of capabilities.
How will Germany spend that 35 billion? Like, they've been to rebuild what SpaceX has built is it takes a lot more money, and it probably requires a couple of different companies working together, right? And I think they have some alternative. I forgot, some kind of Biosat or something. I forgot the name. They have some like other alternative, but it's like a tenth of the capabilities of Starlink, right? And every measurement. So what can you actually, like, how realistic is it to actually build a competitor? What would you need for that?
Yeah, and that 35 billion is for more than just building communication satellites. Yeah, I think like that's a really complex European question that Europe has to answer. Like, how are they going to build out strategic capabilities across Europe? I think that number is really just a big signal from Germany of they're getting serious about space. France is certainly a very serious player as well, and even we're particularly conscious and aware of the Netherlands. They're building their own sovereign capabilities as well. One of which, a mission called PARMI. They're already looking towards key technologies like refueling, and so we're building the propulsion system for that PARMI mission, which is their flagship Earth observation installation. But yeah, like I wish I knew exactly how every dollar of that 35 billion was going to get spent.
Well, I guess what I'm asking is, like, do you think, given that you're able to launch multiple times a day on your Aurora plane, can you put some of these satellites? Do you think there will be ever a business line that Dawn does this?
So eventually, yes, the point is to get to orbit. we see a lot of steps in between that. Because we're bringing the price down so much, there's a lot more market in everything before we get to orbit. So that includes suborbital microgravity. It includes all these, threat representation applications that we talked about. There's actually a lot of really cool non-space things you can do with a space plane.
Stefan, will Dawn eventually become a bigger company than SpaceX?
Depends how big space gets.
Well, let's call it. I mean, you don't need to call it numbers, but just like capabilities wise, like what is your vision and how will it be bigger? Or will it be bigger? Maybe it won't.
Well, SpaceX is an interesting one in that they've said the mission is always about getting to Mars, and I think every year their mission gets broader. And in a similar way, our mission is doing the same, in that it really was all about scalable, sustainable space transportation, and we're still doing that, but more and more we're discovering actually there's more and more terrestrial use cases for what we're doing, and so there's a lot of parallels here, and we're finding our mission is kind of expanding in. Yeah, like point-to-point transport could be a big deal. I know SpaceX has kind of talked about that at some point as well, but if you have truly rapidly reusable and reliable space planes that can travel via suborbit, hundreds of thousands of kilometers, like that's a pretty interesting market too. So yeah, we'll see who's the bigger company in 20 or 30 years time, but SpaceX has got a fair lead on us. So I'll stay up.
And what do you? I mean, what do you think of the leaders leading these companies? So we got, I guess, Elon for SpaceX and Peter Beck for Rocket Lab, and yeah, what do you think? What do you think about them as CEOs and leaders, and how do you sort of, I guess, learn or not learn from them and their examples?
I think they all have some traits about them where you wonder, is that a feature or a bug? But that's not.
Like what? Like what?
Yeah. Oh, just tons of stuff. But I think that the interesting bit to focus on is like, what do they all have in common, and that you're quite sure of as a feature. And one thing is that they're just hardcore about execution. Like it's you got to ship the product, the thing has got to work, and they don't compromise on that even one little bit. And I'd like to think we're getting that right at Dawn as well. Certainly, like if you look at any Rocket Lab product, it just looks like it should work, and 9 times out of 10 it does as well. So there's some pretty solid theory in there, I think.
One of the things you've always been very proud of, and I think you mentioned it last year when we spoke as well, is that you actually didn't raise a lot of money until now, right? I think you generated more sales than, I guess, before you raised the SeriesB, than what you raised in capital to grow. How do you think about this now in the context of, SpaceX going public, raising 75 billion, I think, with this IPO, and, probably also more capital being available to things that you want to build?
Yeah. Like with this SeriesB, we'll almost have equity sale catch up to real sales. Like we'll still have more real revenue come into the business than VC ever, which is still pretty unique.
Very impressive.
Like, yeah. Like, and we're super happy with that. And the reason I actually would like to keep it that way if we could is because I think it really does help keep the company grounded in solutions that matter. Like too much capital can very quickly let you stay on a bad idea for too long. Like I've seen that so many times where a company is pushing an idea and they're making great technological leaps forward, and it all looks really, really good, and they raise one round of 50 mil and then 100 mil and then 300 mil and then 600 mil, and you're like, wow, this company is absolutely on a tear, but there's been no commercial traction, there's been no actual technology demonstration, and then all of a sudden it's like the investors just lose faith and they go, hold on, why are we spending all this money? Where's the traction? Like all these LOIs for launch, does it actually mean anything? And it all just comes crashing down, or it has to get bailed out. Like I think Relativity Space was a really great example of this. They raised well over $1 billion, developed all this cool technology of 3D printing whole rocket stages. Do they do any of that now? Nope. And it got more or less completely bought out by a single party. All the existing investors involved in it got pretty much annihilated. I don't want to be a company like that. I think we've shown that we have a real business, we have real customers, and we can work on things that exponentially develop over time, like building real capabilities within the company that just get better and better every year. Like our manufacturing gets more and more efficient. our ability to do rapid design iteration, lots of small steps forward, gets better every year. And I think those sorts of muscles is what made SpaceX really, really good, especially in the like 2010s to 2020s timeframe. Like the iteration cycle that they had on the Falcon program is just crazy how far that program progressed from like one key customer, which was NASA for the like CRS contracts, like commercial resupply, through to reusability, and then getting that thing to 150 flights a year. Like that's just an absolutely phenomenal exponential curve that company drove for that decade.
Yeah, Stefan. I mean, yeah. So you just raised a round, and we were I think like a couple of percent of that round, and we're really excited to support you. What was it like raising money? And I think like as a New Zealand company specifically, you don't have the same access necessarily to capital that you would in California or Silicon Valley. And I think the perception, even as we were kind of helping you raise some of this money, people were surprised. They didn't know that New Zealand had such a company, or that you could achieve whatever you had, like, what was it, like eight figures of revenue, maybe getting close to 9 figures of revenue, right? Without being on people's radars. Most major VC firms are not aware that you even exist. What was that process and journey like? And I guess, do you think there's an advantage or a disadvantage to being in New Zealand? Do you plan to eventually have more US presence? How do you think about that?
Like, it's definitely a double-edged sword in that like our fundamental cost of operating is much lower. The difficulty of getting stuff done, especially in government and regulation and infrastructure and stuff, it's like that's all way easier down here. So that's part of the formula of why we're able to be so capitally efficient. It's what worked so well for Rocket Lab as well. But yeah, the double-edged sword is like it is harder to get visibility in the States. And there's some particular reasons that we haven't wanted to incorporate as a US company as well, like particularly for like ITAR reasons. We want to be able to supply this technology more easily to Europe. So we've made some decisions to not incorporate in the US, and that again makes it harder to get visibility in the US. So there's some structural trade-offs that we've made as a company, but I believe they'll play out well in the long term in terms of like actually going to the US and raising capital. I think once you get the conversation and you start selling the company of like, this is our vision, this is our mission, this is the traction that we've had so far, these are the financials, like the story somewhat speaks for itself. So massive opportunity therefore for us to just get the name out more. I think once we do, more often than not, people see the light. They see what we're doing down here, and they see how this model follows in the footsteps of so many great companies.
Yeah. So, and one last question for me on that. Like you mentioned that you chose not to go and register the company in the US for ITAR reasons. Is part of that also that you feel like this technology should be accessible to other countries that are broadly aligned with Western values like Europe, and that kind of given the US posture now around maybe pulling out of NATO or sort of being flip-flopping into the current administration, not supporting allies, was there some political kind of considerations there that you personally as a CEO had to make, or is it purely commercial reasons?
Yeah, it's less of like a moral, like, oh, I want to democratize this technology for the world, because it is a highly controlled technology and for good reason. So, but ITAR is this particular set of rules that certainly leaves us, it certainly narrows our options or creates a whole lot of extra paperwork every time you want to go supply this technology to, even the Netherlands or Germany. There's just a whole other party involved. And considering we were doing so much of this development outside of the US anyway, all of the development outside of the US, it didn't really make sense to implicate ourselves in that way. It's disproportionate hurdles for payoff. So yeah, that's just the decision we made.
Cool. I got to stop Mark here, otherwise we're going to be here for another 3 hours. But Stefan, thank you so much for joining us again, and congratulations on the SeriesB. We're super excited to be part of it, and hope to speak to you again soon and hear more about the progress.
Yeah, thanks very much. Super excited to have you guys part of the round as well. Right, catch you in another
Thank you.
time.
Speak soon.
Thank you for tuning in to TechMates. If you enjoyed this episode, be sure to subscribe, leave a review, and share it with friends. We'll be back soon with more stories of Kiwi and Aussie founders reshaping the future and disrupting down under. Until next time, keep dreaming big and daring to disrupt.